So let's see, stand this up here, perpendicular here, and somewhere here is the force F1, and its magnitude is 50 pounds. Then its direction is given by a triangle. The ratios as 7, 24 and 25. Then we have another angle, another force F2, that's given by the magnitude 180 pounds. Then the angles are given. We have this as 60 degrees. Then we have this angle here as 135 degrees. Then you have this angle here as 60 degrees. These are the three angles given, and the question here is to determine the magnitude and direction of the resultant force Fr. So, looking at this problem, since there are only two forces acting at the point O, your equation will be your Fr equals the first force factor, and then you have the second force factor. You add the two force factors, and that should give you the resultant. Now, to do it in actual practice, we need to write this as Cartesian vector form. We need the force F1 as Fx I F y1j and Fc1k. We gotta do the same thing for the second force. That means we need to do Fx2 I Fy2j and Fc2k. So we need the component here of Fx1, Fy1, and Fc1, and we need this here, which is Fx2, Fy2, and Fc2. So how do we go about doing this? Let's say you want to look at the first force, and you want to find the components Fx1, Fy1, and Fc1 given that information. For the first force, how are you going to find it? Let me make it a little bit more clear. This force is in a plane, and that plane happened to be y or z. It's really not a three-dimensional force. It's in a plane, or the plane of the blackboard. So, what's the x component? Y. It means 0, that's true, but why? Yeah, that's right. For that force, when you take these two axes and when you take the components, you're going to have one component going in the y direction, and you get another component in the z direction. And these two components will be sufficient to define the force. So the x component will be 0. Another way of looking at would be, see, the x component for that force will be F cosine of gamma. Now, F is 50, so sine gamma is going to be 90. That's the angle between the force and the x-axis. So that's 0, so that gives you a 0. Alright, we're going to complete this problem in the next lecture. Now your new problem set J plus the 2, 4, and that time K. So those are the main components. Here you have this, that's F R X, or the X component of the force. Then you have this, that's the Y component of the resultant force. And then you have this, which is the C component of the resultant force. Then you need the magnitude for the resultant force, and you just use the straight equation. And if you take the X component, which is 90, you square that. Then you take the Y component, which is negative 11328, square that, plus FRZ, and that's 42. You square that, and if you go to the actual numbers, this should be close to 150.7 pounds. So that's what you get as the magnitude. Then you need the 3 angles to define its direction. So those angles are going to be alpha, beta, gamma. You get cosine inverse F R X, and that's 90. You divide this by magnitude, which we just found as 150.7. That should give one angle. Then you go cosine inverse F R Y, that's negative 113.28. Divide this by, again, magnitude, which is 150.7. Then you have the third angle, which is cosine inverse, that's F R Z, and magnitude is 42. Divided by its resultant, that's going to be 150.7. So again, that's just the direct substitution of the values. And if you go to the numbers, this should be 53.3. This is going to be 138.8. This is going to be 73.8, all being in degrees. So that's the procedure you need to follow when you have a set of forces in 3 dimensions. Now, it's still a 3-step process. So this part was step 1. When you looked at every force and then you converted that into a force vector. So whether you have 2 forces or if you have more than two forces. It really doesn't matter. In the first step, you're going to convert every force you have in vector form. Then somewhere around here, you have step 2, where you took each individual force vector and you added the components to find the resultant force vector. Then finally, somewhere here, you have step 3, where once you had the resultant force vector, then you found the magnitude and you found the angles that define the force vector itself. So that process doesn't change whether you're working with the problems which are in 2 dimensions or you're working with the problems which are in 3 dimensions. The only difference which shows up when you have problems in 3 dimensions is the third component. You have FZ2 here, you have FC1 here. Same thing happens on here. You get a Z component, so you have 3 numbers to work with, then you get extra 2 angles. So in the plane problems, you just need the magnitude and 1 angle with the x-axis. But now in this case, you not only need the magnitude, you also need 2 angles more, which defines the direction with respect to the 3 axes. So any questions on this? Coordinates of 2 points. The given coordinates for let's say point A, those are xa, ya,